Hi, welcome. So in this video, I'm just going to briefly go through some suggestions I have for using integration by parts. So my first tip is that in order to choose your u and your dv, you generally want the derivative of u to be something simpler. So you're going to pick a u that is complicated that you're not really sure how to handle, and then take du, the derivative of u, with the idea that it should get simpler in some way. That's because this du is going to be in the new integral you're trying to solve, and that new integral with the du, you want to be easier. So the hope is that you're choosing something in the original integral, making it easier by taking its derivative, and then it will then show up in the new integral you have to solve. So to go along with this, in terms of choosing a u that's going to get simpler, I have an acronym to share that will help you know which type of function to choose for your u. So this is an acronym I learned when I first learned integration by parts, and I've seen it in textbooks since then. It's LIATE or LIATA. I don't know how you'd want to say it, it's just a made up word, but the letters are LIATE. So L means logarithms, and this is what you're going to try first. So if you have a logarithm in your integral and you're using integration by parts, try to pick this as your u first. Next is I for inverse trig functions. So this would be if you had an arcsine, arccosine, arctangent, that sort of thing. I personally don't really care much about the derivatives or integrals of these functions, so you don't see this very much if you're taking a class from me, but it is one of the letters in the acronym, and if you're in a different class or I'm not your teacher, this is just good to know. Then next is A. It means algebraic, so this would be x to some power or something with x's in it. Then we have T for trig. This would be any trigonometric function, sine, cosine, tangent, that sort of thing. And then lastly, your last option for choosing u would be an exponential, so like e to some power, or if you had a different number to some power, I guess. This would be sort of like your last resort for choosing u. Obviously, this isn't going to work all the time perfectly, but it's a good rule of thumb to use if you're just trying to know how to choose u. Then, once you've chosen u, the dv is what's left over. Then, after this, I just have two more brief suggestions for you if you're using integration by parts. So, my next tip is that you shouldn't worry about any plus c's until you get to the end of the integral you're trying to solve. So if you try to keep track of plus c's as you go throughout the process of integration by parts, you're going to just have a lot of them to deal with, and it really just matters that at the end you have that plus c there. So my suggestion is to just not worry about it until you get to the very end, with the knowledge that if you put all of the plus c's in there along the way, they'd kind of all be combined into one brand new constant at the end, and you're just going to write the plus c at the end to handle that. And lastly, don't be afraid to just try things out and maybe even integrate by parts twice. So when you're doing integration by parts, we have these like tips for how to know how to choose u and dv, but really you can just try something, and if it doesn't work right away and you're not seeing it get any easier to do, just pick something different. Just try swapping the u and the dv, or try something different entirely. This is just one method to help us solve integrals, and it's supposed to be something you can try out to see if it helps make things easier. Also, sometimes you do integration by parts once, and then the new integral you've created to hopefully be easier also requires integration by parts. So don't be afraid to just continue on with the process. As long as the integrals seem to be getting simpler and you can see the end in sight, try it again. Hopefully that'll get you there eventually. So just remember, push forward, do your best, don't be afraid to try things, and just keep going with the problem. Okay, so with those tips in mind, hopefully you have some suggestions that'll help you out when you're doing integration by parts problems. Thanks so much for watching, and I will talk to you in the next one.